this video, I'm going to answer the question, why is any base raised to the power of 0 equal to 1? Why does this work? And the way I'm going to approach it is using a pattern. In math, a lot of times patterns are there, and this is one place where I think if I show it using a pattern, you're going to pick up on it. You're going to see why it is, and then I'll show you with a couple of different bases why that pattern holds no matter what. So we're going to start out with a base of 2. So let's just start out with 2. And I'm going to just start with raised to the 4th power. I could start with the 5th, the 6th, the 7th, 3rd, but I don't want to go through so many that this video gets crazy long. So I'm just going to start with 2 to the 4th. I think you'll pick up on it with this as a starting point. And then we'll have 2 to the 4th is really 4 2's multiplied together. That's what 2 to the 4th means. But if you multiply those 4 2's together, you will get 16. And then we're going to drop the power by 1. So I'm going to take 1 away from the power, go from the power of 4 to the power of 3. And what happens here is now we're just going to have 3 2's multiplied together. And when you multiply those 3 2's together, you get 8. So before I go to the next power, let's take a look and see the relationship between 16 and 8. 8 is half of 16, or another way to think about that, if I divide by 2, and more importantly take that 16 and divide it by 2, you will get 8. So let's go ahead and look at 2 squared. So 2 squared is 2 2's multiplied together. 2 times 2 is equal to 4. And again, if you look at the 8 and the 4, the relationship there, if you divide 8 by 2, you will get 4. Okay, so let's move to 2 to the 1st power. So still dropping the powers by 1. Almost there now. And we have 2 to the 1st power is just 2. It's itself. But if I come over here and look at the pattern, 4 divided by 2 gives me 2. So this is a pattern that will always continue. I mean, you could have started up at like 2 to the 100th if you wanted to, and then 2 to the 99th all the way down. You'd be working with some really big numbers, but you would still see as you drop the power, you can take that result, divide it by 2 when the base is 2, and get the new number. So now, what we've all been waiting for, 2 to the 0 power here. What is 2 to the 0 power? Well, let's come over here and divide this 2 to the 1st power result by 2 to see what we get. So 2 divided by 2, or 2 divided by itself, will just be 1. All right, so you're saying, okay, well that worked with 2's, but will it work with other bases? And let's just go ahead and see what happens when we do 5. So I'm going to start with 5 to the 4th power. Again, I'm just picking that power because I think that's a big enough power to develop the pattern and make things work. So we will have 5 multiplied together, and actually 4 of them multiplied together. And so that ends up being 625. Drop the power by 1, 5 cubed. Well, now that's 5 times 5 times 5, 3 5's multiplied together. And if you figure that out, you get 125. The relationship here between 625 and 125, it's not as easy as with the 2's, but if you were to take the 625 and divide it by 5, the new base that we're working with, you would get 125. And then if you did 5 squared, you get 5 times 5. That's going to be 25. And if you took 125 and divided it by 5, you get 25. And getting down to 5 to the 1st, which is just itself. And if you take 25 and divide it by 5, lo and behold, you get 5. So then we're down to that 0 power again. And if we continue the pattern of dividing by 5's every time we drop the power by 1 for this particular base, 5 divided by itself is 1. Okay, so hopefully you're seeing now why this is working with any base. It's the same basic pattern. As you drop those powers by 1, you're dividing by that base, and eventually you're going to get to a point like we did up here where, right here, you're dividing 2 by itself to get to the 0 power. Here you're dividing 5 by itself to get to that 0 power result of 1. And just for craziness here, let's finish out this video with some algebraic expression like x plus 1, and I'm going to start with that raised to the 4th power. I am not going to distribute this all out and get the result, which would be like x to the 4th and a bunch of other terms. I'll let you look at the binomial theorem if you want and figure that out on your own, or you can do it the long way. But basically the idea here is that we still have 4 of those things multiplied together when we start to the 4th power. And then x plus 1 cubed is 3 of those things multiplied together. And what's happening from here to here, it's not as easy to see as with the numbers, but when you divide this x plus 1 times x plus 1 times x plus 1 times x plus 1 by 1x plus 1, you essentially cancel out that x plus 1 factor. And if you've been working with this stuff in your algebra class, you will have seen this. You cancel out common factors when you divide an algebraic expression by another algebraic expression. So canceling out leaves us with the 3 of them essentially. And the same pattern then comes down to x plus 1 squared. And we get x plus 1 times x plus 1. And again, we can get from the cube to the square by dividing out one of those common factors of the x plus 1. And then we come down to x plus 1 to the 1st power. And well, that's just itself. But we can again get from the squared to the 1st power result by dividing out and x plus 1. And then we get to the x plus 1 raised to the 0 power, which it looks like it should be more, but if we continue this pattern of dividing every time we drop a power by 1, just like we did with the numbers, it's the same thing. We're dividing by the base, and the base in this case is just a little bit more complicated looking than a number, but it's still the same principle in math. We're just going to divide by x plus 1, and in this case you get x plus 1 divided by itself, x plus 1, and you get 1. So even with something that's an algebraic expression, not just a numerical base, you still get down to this point where you're essentially going from the 1st power to the 0 power and dividing by itself to get 1 if you're looking at it in this pattern that I've created here. I hope that helps you understand why anything to the 0 power is equal to 1, and thank you for watching.